Okay class, now let's talk about higher order partial derivative. So what is the higher order derivative? So let's do some revision about the derivative. So if before this we have a function with one variable, for example you have y equal to 7x cubed minus 5x squared plus 4x plus 3. Okay, so you differentiate y with respect to x, you will get y prime equal to 21x squared minus 10x plus 4, right? Okay, and then you can actually do the second derivative, okay, which will give you y prime, or if this one is dy over dx, this one will be d square y, this one is y. This one is y, so this one will be the derivative of y with respect to x. So this one will be the d square y dx squared, the second derivative. Okay, so you just need to differentiate with respect to x again. Okay, so you have 42x minus 10. Okay, and then you actually can differentiate the third time. So this one is the third derivative, or the symbol would be d cube y over dx cube equal to, so just differentiate, you get 42, and you can do one small because this one is not checked 0, so you have fourth derivative, or in the symbol you will have d fourth y over dx4, so it gives you 0 because constant, right? So if you continue, you will always get 0 because 0, 0, 0. Okay, so there's the end. So you can differentiate this up to the fourth derivative. So more than one derivative, all of this is called as higher order derivative. Means we differentiate the function more than one time. Okay, we differentiate the function more than one time. But what is the difference between the function with one variables and the function with two variables? It's just that sometimes you have to differentiate in terms of x, sometimes you can also differentiate in terms of y. Maybe the first time you differentiate in terms of x, and then the second time you will differentiate in terms of y. Okay, so if you differentiate in terms of x, for example, you have okay, let's see first the definition of the higher order, right? So we want to see the higher order partial derivative. So there are 4 second order partial derivative of function of two variables. So this one is this one is second derivative, means we differentiate second time. So let's say you have the function z equal to fxy. Okay, so if you differentiate once, okay, if you just differentiate one time, you will get either fx or you will get fy. If this fx is differentiated for the second time with respect to x, it will give you fxx. But if the second time you differentiate it with respect to y, you will get fxy. Okay, same goes to fy. The first time you differentiate it with respect to y, and then you do the second differentiation, you can make it with respect to x. So what you will get? fyx. If you differentiate the second time also with respect to y, what you will get is fyy. That's why you have 4 second order. Either you have fxx, you have fxy, you have fyx, or you have fyy. Okay, so it can be either one of these. Okay, so let's see here. The first time you are differentiating the function of f with respect to x, and then you differentiate it again with respect to x, it gives you fxx. Okay, the first time you differentiate your function with respect to y, and then you differentiate it again with respect to y, so you get fyy. Okay, because we differentiate it 2 times and we have 2 variables, so it will be a variety of the derivative, okay, the partial derivative. So if this one is the mix, means that the first one you differentiate it with respect to x, and then the second time you want to differentiate it with respect to y, so what you will get is fxy. Okay, you differentiate with respect to x first and then y. You just need to follow the order here. Okay, for this one means that you differentiate with respect to y first and then you differentiate it with respect to x. So this one is the higher order derivative, means that you differentiate the function more than one time. Okay, so more higher order partial derivative can be obtained by successive differentiation, means kalau you nak 3, okay, maksudnya kalau macam ni 3, maksudnya apa? Kita dah differentiate 2 kali with respect to x, kita differentiate lagi sekali with respect to x, so you get lah 3 kali fxxx. Okay, you dah differentiate 3 kali, okay, with respect to x, with respect to y, with respect to x, and then you differentiate lagi with respect to x. So kalau macam notation yang ini kita guna daripada belakang, belakang, yang ini daripada depan. So you see x, y, x, x. Okay, you see here, y kat depan, ni kat depan, dia jadi belakang, dia terbalik. Okay, dia terbalik. So this one is the higher order derivative for the partial derivative, higher order differentiation for the partial derivative. Okay, so this one is just geometric interpretation of the second order partial derivative. If the value of your fxx, means the second differentiation with respect to x, is greater than 0, means your function is concave up the direction, the x direction. If your function fyy is greater than 0, means your function is concave up the y direction. While if you have mixed derivative, okay, you have the derivative of xy or you have derivative of yx, it will show you how the rate of change of the function fxy in the x direction is changing as we move in the y direction. So the mixed partial derivative will give you how perubahan kadar function ini berlaku dalam direction y bila kita bergerak di dalam y direction. Okay, dalam direction x, okay, bila kita bergerak dalam y direction. Kalau fyx means perubahan function f pada y direction bila kita bergerak, pada y bila kita bergerak pada x direction. Okay, so this one is just the interpretation. So let's see the example here. So you have a function z equal to fxy equal to 6x. So let me bring this one to somewhere else so that we can do it together, because here you already have the answer, right? So we do it here. So sorry, it's not complete. This one is the equation actually. Okay, so let's say you have a function z, okay, or a function fxy equal to 6x squared minus 3x squared plus 4y cubed. You need to determine the value of d squared z dx dy. So how you want to know which one to do first? You start from the back, means that you need to differentiate with respect to y first, and then you differentiate it with respect to x. Okay, you need to differentiate with respect to y first and then you differentiate with respect to x. So how to write it? It will be the differentiation with respect to x for the one that you already differentiate with respect to y. Okay, means you buat y dulu baru you buat x. Okay, you cari dulu apa the differentiation of the function with respect to y. So we have to find the differentiation of the function with respect to x. What is this one? Fy. What is your fy? Okay, so for me, if you want to be easy, okay, my hint is, if you want to be easy, whenever you already get the function, do this. Write your fx, write your fy. Later you just use, okay, what is your fx? Fx is the derivative with respect to x. So you differentiate this one, you will get 12x. You differentiate this one, 3, negative 3, and y will be a constant. So you just put negative 3y. Differentiate x, you get 1. So there's nothing here, right? So this one, y will be a constant because now we are differentiating with respect to x. So now you do the same. You want to differentiate with respect to y. So we just need to use the value of, just need to differentiate y. Okay, we just need to differentiate y. So you see, when you want to differentiate y, x will be the constant. So this one, you differentiate constant, you will get 0. So you differentiate y, so x is a constant. So let negative 3x is a constant. Just write it here. It is a constant. So differentiate y, you get 1. So you no need to write. If you want to write pun tak ada masalah. Okay, and now differentiate y. So this one will be 12y squared. Okay, so you have here is negative 3x plus 12y squared is your fy, and this one is your fx. So now you see, you want in the bracket is fy. So just substitute your fy here, negative 3x plus 12y squared. So what you want to do here is you want to differentiate this function with respect to x. So whenever you want to differentiate with respect to x, y is a constant. So you already get plus 0 because this one is a constant. And then you differentiate this one, negative 3x. Differentiate, you will get negative 3. So negative 3 plus 0, the answer is negative 3. It's easy. Right? So if you see the second one, it want it to be, okay, the first one is differentiate with respect to x. So let's write differentiate with respect to x. And then the second one, differentiate with respect to y. So you nak fxy. So apa masuk fxy? Masuk fxy adalah you nak differentiate, ambil yang belakang, kepada y, function yang dah pun di-differentiate kepada x. Okay, so df dx is fx. So what you need to do is you just substitute your fx. This one is your fx, right? So 12x minus 3y. So what we want to do to this function, we want to differentiate it with respect to y. So this one is a constant, 12x is a constant. So constant differentiate dapat kosong, tolak. Differentiate 3y dapat 3. So kosong tolak 3 is also negative 3. So if you see here, okay, if you see here, fyx, yang ini fxy, sama kan, negatif 3, ini pun negatif 3. But actually is a coincident. Okay, is not confirm the equality. So it's give you this theorem. Okay, so if you have fxy, you have fyx are continuous over this region. So fxy equal to fyx. This one is equality of mixed partial. Okay, so it will give you the same value if it's continuous over this region. Okay, but the mixed partial does not hold for all function. Tak semestinya. Okay, so you just need to do it. Janganlah awak ambil awak dah cari fxy equal to 3. Kalau dia tanya awak apa dia fyx, awak terus letak 3. Tak boleh. Dia tidak kepada semua function. Does not hold for all function. So you just need to find it. Gunakan cara partial derivative. Alright, so teruskan. So now we want to find next is this one, d square z dy square. So apa maksud d square z dy square? Maksudnya kita differentiate kepada y 2 kali. Mula-mula kita dah differentiate kepada y. Okay, kita differentiate kepada y, benda yang dah pun di differentiate kepada y. Sorry, it's not f, it's z. Okay, benda yang dah pun di differentiate kepada y. So here you want the function of y, I write it as f. It's okay. You can use z, you can use f. Okay, so you want to dy. So what is your fy? Your fy is here, negative 3x plus 12y square. Okay, you want to differentiate it to y. So x will be constant. So differentiate constant 0 plus differentiate this one will be 24y. So what you have here is 24y. Okay, and then this one is fyx at 0.32. Fyx apa dia? Fyx nak tulis dia, ambil dekat belakang d dx, okay, df dy, macam tu. So apa yang kita nak dalam kurungan? Yang kita nak dalam kurungan adalah fy. So fy kita adalah negative 3x tambah 12y square. Kita dah cari tadi. So kita nak differentiate kepada x. So kita dapat negative 3. Yang ni constant. Okay, because kita differentiate kepada x. So this one will be 0. So what you get is negative 3. There is no point untuk kita substitute. So the value is negative 3. Okay, so this is how you do a partial derivative. You find the gradient of a traces by using the partial derivative. You find the rate of change by using the partial derivative, and also we find the higher order partial derivative. The concept is equal to the normal derivative, the differentiation process, the technique of derivation. Okay, it's just that it involves two variables. Okay, so we just need to do more exercise for us to expert in imagine which one you want to differentiate, which one will be the constant. Okay, if you want to differentiate in this direction, what happened to this value? So we need to do a lot of practice. Okay, but don't worry, I will do with you together in next class in Monday. Okay, just go through the video. Okay, take notes. Okay, you can try to do a partial equation. Okay, just I think a partial equation is very direct about partial derivative and also the limit and continuity. So that's all for this week. Thank you everyone. See you on Monday. Assalamualaikum.